In this lesson, we are going to talk about the reciprocal trigonometric ratios. First of all, let's see what exactly reciprocal means. Reciprocal means two numbers or two expressions with the product equal to 1. For instance, 5 and 1 over 5 are reciprocal because 5 times 1 over 5 gives you 1. Or x squared plus 1 and 1 over x squared plus 1 are reciprocal because if you multiply these two, you're going to get 1. Now we are going to define reciprocal trigonometric ratios. Now we are going to define three new ratios based on our previous trigonometric ratios, sine, cos, and tan. These ratios are called cosecant x, secant x, and cotan x. Now exactly what these expressions are is very simple. We define cosecant x to be the inverse of sine x, which is 1 over sine x. We define secant x to be 1 over cos x, and cotan x to be 1 over tan x. Now take one of these ratios, let's say cosecant x. Remember, cosecant x is cosecant x over 1. If I find the cross multiplication here, I get cosecant x times sine x is equal to 1, which is the definition of reciprocal expressions. Or secant x times cos x is going to be equal to 1, and cotan x times tan x is going to be 1 too. Now we are going to do a couple of examples to see how we can use these new expressions. The first example, we have a right triangle with three sides given. AC is 4, BC is 3, and AB, the hypotenuse, is 5. We are supposed to find the 6 trig ratios for angle A. So this is the angle we are talking about. By definition, we know that sine A is opposite over hypotenuse. Now, opposite to angle A is side BC, which is 3, over hypotenuse, which is 5. Cos A, by definition, is adjacent over hypotenuse. For angle A, the adjacent is 4, and the hypotenuse is 5. And tan A is opposite over adjacent, which is going to be equal to opposite is 3, adjacent is 4. Now we are going to find the reciprocal trig ratios. The first one is cosecant A, which by definition is 1 over sine A. If sine A is 3 over 5, so cosecant is 5 over 3. The other one is secant A, which is 1 over cos A. Cos A is 4 over 5, so secant A is 5 over 4. And the last one is cotangent A, which is 1 over tan A. 3 over 4 is tan A, so the reciprocal of 3 over 4 is 4 over 3. Now it says determine the 6 trigonometric ratios for angle B now. Now we do the same thing. We say sine B is opposite, which is 4, because opposite to angle B is 4 and hypotenuse is 5. Cos B is adjacent to angle B, which is 3, over hypotenuse, which is 5. and tan B is opposite to angle B, which is 4, over adjacent, which is 3. Now, cosecant B is just the reciprocal of sine B, which is 5 over 4. Secant B is the inverse or the reciprocal of cos B, which is 5 over 3. And cotan B is the reciprocal of tan B, which is 3 over 4. The next example, we have the cosecant A or secant B or cotan C given. We are supposed to find the measure of each angle. The first one is cosecant A is 1 over A. We know that cosecant is 1 over sine A. So we say 1 over sine A is 8. If we flip the two fractions, we get sine A is equal to 1 over 8. If we use the calculator and the inverse function for sine, we get that A is approximately 7 degrees. The next question, secant B, which is 1 over cos B, is equal to 5 over 2. So cos B is 2 over 5. Again, using the calculator, we will find that B is approximately 66 degrees. And the last one, cotan C, which is 1 over tan C, is equal to 5 over 16, or tan C is 16 over 5. If we use the calculator, C is approximately 73 degrees. The next question says, determine two angles between 0 and 360 that have a cosecant of -2. We know by definition that cosecant is 1 over sine A, which is equal to -2 over 1. If I flip the two fractions, I get sine A is -1 over 2. Now, if you remember previously from section 4.1, first we have to find the reference angle here. The reference angle here is 30 degrees because sine 30 is 1 over 2. Remember, 30 degrees is one of those special angles. Now, since sine here is negative, if you remember the unit circle, in quadrant 1, all the three trig ratios were positive. In quadrant 2, sine was positive, the other two were negative. And in quadrant 3 and 4, because y is negative, sine was negative. So this means that angle A has to be either in quadrant 3 or quadrant 4. Now, the 30 degrees is going to be somewhere around here. To find the corresponding angle in quadrant 3 and 4, I'm going to find the reflection of this point on the origin, and I'm going to get a point here, and also I'm going to find the reflection of this point on the x-axis, and I get here. Now, to find this angle, again, remember counterclockwise, we know that this angle is 30 degrees. So this has to be 30 degrees. So this full angle is 180 plus 30, which is going to be 210 degrees. So that's one of the angles. The other one that we have to find is this angle going from here to here. To find this angle, we know that this angle, again, this small angle is 30 degrees, so I'm going to subtract 30 from 360. I get 360 minus 30, which is going to be 330 degrees. So the two angles that are going to have a cosecant of -2 are 210 and 330. The next example, we have an angle theta which satisfies the relationship cosecant theta, cos theta is -1. We are supposed to write the left-hand side in terms of sine and cos. We know that cosecant theta is 1 over sine theta, so we are going to write cos theta over sine theta is equal to -1. Again, cosecant is 1 over sine. The next part of the question says, what is the relationship between sine theta and cos theta for this angle? We found in part A that cos theta over sine theta is -1, -1 over 1. If we crisscross this one, we get cos theta is negative sine theta. This means that the absolute value of cos and sine are equal, but they are opposite signs. That's the relationship between the cos and sine of this angle. The next part of the question says, determine two possible values for theta, and we are not supposed to use a calculator. We found previously that cos theta is negative sine theta. And from this expression, we know that the absolute value of sine and cos are the same. The only angle that sine and cos are the same is one of those special angles which is 45 degrees. So our reference angle is going to be 45 degrees. Now, since sine and cos, they have different signs, you have to go through 4 quadrants and see which one satisfies this condition. In quadrant 1, sine and cos, they are both positive, so they don't satisfy this condition. In quadrant 2, we know that sine is positive, but cos is negative, so this quadrant is okay. In quadrant 3, we have both sine and cos negative, so this is not okay, quadrant 3. Quadrant 4, we know that cos is positive, but sine is negative, so they are opposite sides. So this quadrant is also okay. So we have to find the reflection of this point on the y-axis, which is going to be here. So this is one angle that we have to find. This angle, remember, this angle here is 45. So I can say one of the angles is 180 minus 45, which is going to give us 135. The other angle is going to be reflection again of this point on the x-axis, which is going to be here, because now we are in the 4th quadrant. So we have to find this angle now. This angle is 360 minus 45, which is going to give us 350. So the two possible values for theta are 315 and 135. If you find the sine and cos of these two angles, you will see that they are the same, the absolute value, but they have different signs. The next part of the question says, give an example of other information needed to determine a unique value for theta. For instance, one other information, if we know which quadrant theta is located, we can uniquely specify is either 135 or 315. For instance, if I say theta is an angle which is in quadrant 2, then we know the only possible value is 135. If we say it's in quadrant 4, then the value is 315. The last part of the question says, if secant theta is known to be negative. Remember that secant theta is equal to 1 over cos theta is negative. So this means that cos theta has to be negative. Cos is negative. Remember, cos is x over r. And cos is negative only, one of the quadrants that cos is negative is going to be quadrant 2 or 3. But previously we said that the angle theta has to be in quadrant 2 and 4. So this means that theta must be in quadrant 2. We also said that the answer theta in quadrant 2 is 135. So theta has to be 135 degrees. And it says, what is the cosecant theta? Cosecant is 1 over sine theta, which is 1 over sine 135. And we can use the calculator to find 1 over sine 35, which is going to be equal to 1.414.